Hello students, welcome to our live APS classes, and as all we know that this is our foundation course especially for the students from 9 to 12, and in our today's live lecture we will continue with our new chapter for class 12, and the name of the chapter is General Principles and Processes of Isolation of Elements, and this is our chapter number 6. So first of all, welcome to all the students who joined with us our live APS classes. And remember one thing, that this is the syllabus for the term 1 examination that is to be held in November 2021. So let us start with our 6th chapter, that is the General Principles and Processes of Isolation of Elements. And our first question regarding this chapter is, Cinnabar is an ore of Hg, Ag, Sn and Al. So there are 4 options for the question number 1, that is Cinnabar is an ore of Hg, Ag, Sn and Al. So you have to choose the right answer for the question number 1, that is Cinnabar is an ore of Hg, Ag, Sn and Al. That means there are 4 options. So Cinnabar is an ore of Hg, that is mercury, not Ag silver, not Sn and not aluminium, but Cinnabar is an ore of Hg. So here this is the right answer for the question number 1. Next is the question number 2. Pyrolysis is an ore of. Pyrolysis is an ore of. Options are Ag, Hg, Sn and Mn. Pyrolysis is an ore of either Ag, Hg, Sn and Mn. So here pyrolysis is an ore of Mn, that is manganese. Pyrolysis is an ore of manganese. So here this is the right answer, that is pyrolysis is an ore of manganese. Next is the question number 3. Malachite is an ore of. Options are Hg, Cu, Sn and Mn. And your question is malachite. Malachite is an ore of either Hg, Cu, Sn and Mn. It is the question number 3. Malachite is an ore of. So here beta, malachite is an ore of copper. Not Hg, not Sn and not manganese, but malachite is an ore of copper. So here this is the right answer for the question number 3, that is malachite is an ore of copper. Next is the question 4. The process employed for the concentration of sulfide ore is. The process employed for the concentration of sulfide ore is. Options are froth flotation, B roasting, C electrolysis and D is calcination. The process employed for the concentration of sulfide ore is either froth flotation process, roasting, electrolysis as well as calcination. And this is your question number 4. So the process that is employed for the concentration of the sulfide ore is froth flotation. Froth flotation. So froth flotation is the process that is employed for the concentration of the sulfide ore. The rest are the processes are not employed for the concentration of sulfide ore, that are either roasting, electrolysis and calcination. But only froth flotation is the process that is employed for the concentration of the sulfide ore. So here this is the right answer. Next is your question number 5, and your question number 5 is zone refining is used for the. Option A is concentration of an ore, B reduction of metal oxide, C purification of metal and D is purification of an ore. Zone refining is used for either the concentration of the ore, reduction of metal oxide, purification of metal, and the purification of an ore. So you have to choose the right answer for the question number 5. That is, zone refining is used for the. So here beta, zone refining is used for, and it is question number 5. Zone refining is used for the purification of metal. Only zone refining is the process that is used for the purification of the metal. That means with the help of the zone refining, we can easily purify the metals. So this is the right answer for the question number 5. That is, zone refining is used for the purification of the metal, not the concentration of the ore. And by this zone refining, it is not used for the reduction of the metal oxide, and as well as this is not employed for the purification of the ore, but it is employed only for the purification of the metal. Next is your question number 6, and our today's target for our today's live video lecture is of importing 20 MCQ questions or objective questions from this chapter, that is the general principles and processes for the isolation of the elements. The metal always found in the free state is, options are gold, silver, copper, and sodium. The metal that are always found in the free state. जो metal जितना ज़्यादा कम reactive होगा, that means that metal is easily found in the free state. The metal which is less reactive, that means that metal is easily found in the free state. So out of these metals, which is found in the free state, either gold, silver, copper, and sodium. So gold is least reactive. So gold is a metal that is always found in the free state. Gold is a metal that is found in the free state. Found in the free state. So here this is the right answer. That is gold, and it is less reactive. So on the behalf of that reason, it is always found in the free state. Next is your question number 7. Bauxite is an ore of. Options are aluminium, B, calcium, C, copper, and D is zinc. So bauxite is an ore of. Bauxite is an ore of either aluminium, calcium, copper, and zinc. So bauxite is an ore of aluminium. Bauxite is an ore of aluminium. Aluminium. Not calcium, not copper, and even not zinc. But bauxite is an ore of aluminium. So here this is the right answer. Next is your question number 8. And your question number 8 is most abundant element in the earth crust is. Options are oxygen, silicon, aluminium, and iron. So you have to choose the most abundant element in the earth crust. So here the most abundant element in the earth crust, silicon is not most abundant, aluminium is not most abundant, even iron is not most abundant element in the earth crust, but oxygen is the most abundant element. Most abundant element in the earth crust. So here this is the right answer for the question number 8, that is oxygen. This is the most abundant element in the earth crust. Rest are the wrong options. Next is your question number 9. Concentration of sulphide ore is done by. How will the concentration of the sulphide ore take place? Either with the help of froth flotation process, with the help of electrolysis, with the help of roasting, as well as none of these. That means how will the concentration of sulphide ore is taken by or done by? It is your question number 9. That means the concentration of the sulphide ore is done by froth flotation process. Froth flotation process is the only process. Froth flotation process is the only process that can be used for the concentration of the sulfide ore. So by this fourth flotation process, the concentration of the sulfide ore takes place. Not electrolysis, not roasting, and even not none of these. So here this is the right answer, that is the fourth flotation process. So here by the fourth flotation process, the concentration of the sulfide ore is done. Next is the question number 10. Malachite is an ore of. Options are iron, B. Copper, C. Zinc, and D is silver. Malachite is an ore of either iron, copper, zinc, and silver. So here malachite is an ore of copper, not iron, not zinc, and even not silver. But malachite is an ore of copper. So here this is the right answer for the question number 10. Next is the question number 11. Ore of aluminium is bauxite, hematite, dolomite, and none of these. Ore of aluminium is, aluminium किस चीज का ore है? Either bauxite, hematite, dolomite, and none of these. So here beta, ore of aluminium is only and only bauxite. So bauxite is the ore of aluminium. Hematite is the ore of iron. So here the ore of aluminium is bauxite. So bauxite is the right answer for the question number 11. So the ore of aluminium or bauxite is the ore of aluminium. Next is the question number 12. Removal of the unwanted materials like sand, clays, etc. from the ore is known as dash, dash, or dash. Removal of unwanted materials like sand, clays, etc. from the ore is known as either concentration, dressing, beneficiation, B. Separation, refining, and gang. C. Magnetic separation, purification, and gang. D is washing, refining, and amalgamation. So here there are 4 options for the question number 12. That is removal of the unwanted materials. अगर unwanted material का removal करना है, that is sand and clays, and that removal of unwanted materials from the ore is known as concentration. Dressing. Concentration के बाद जो second step आएगा, that is of dressing, and after the dressing the main important step is the beneficiation. So removal of the unwanted materials like sand and clay from the ore is known as first concentration. After the concentration, the most important step is dressing, and when the dressing is complete, the most important process that is involved in the removal of unwanted materials, that is known as beneficiation. So here this is the right answer. Next is the question number 13, and your question number 13 is, for which of the following ores fourth flotation method is used for the concentration? Options are hematite, B is zinc blende, C magnetite, and D is camelite. So for which of the following ores fourth flotation method is used for the concentration? Options are hematite, zinc blende, magnetite, and camelite. Question number 13. So out of these following ores, the fourth flotation method is used for the concentration of which of the following ores? Question number 13. So out of these following ores, fourth flotation method is used for the concentration of zinc blende. So zinc blende is the ore that is used for the fourth flotation method, especially for the concentration. So here out of these following ores, fourth flotation method is used for the concentration of zinc blende. So this is the right answer. This is the question number 13. Next is the question number 14. The powdered ore is agitated with water or washed with running steam of water. The heavy ore particles and lighter impurities are separated. This method of concentration is known as, options are metallurgy, leaching, froth flotation process as well as gravity separation. So, which is the right answer for the question number 14? If the powdered ore is agitated with water or washed with the running stream of water, then the heavy ore particles and lighter impurities are separated. So this method of concentration is known as either metallurgy, leaching, froth flotation process, and gravity separation. So here, beta, when the powdered ore is agitated with water or washed with the running stream of water, the heavier ore particles or lighter particles are separated. This method of concentration is known as gravity separation. Gravity separation. Gravity separation. Not froth flotation process, not leaching, and even not metallurgy. But this method of concentration is known as gravity separation. Next is the question number 15. The oil used as frothing agent in froth flotation processes, options are coconut oil, B, castor oil, C, palmitic oil, and D is pine oil. The oil that is used as a frothing agent in froth flotation processes, either coconut oil, castor oil, palmitic oil, as well as pine oil. It is the question number 14. So the oil that is used in frothing agent, especially in froth flotation process, is pine oil. Is pine oil. Not coconut oil, not castor oil, and even not palmitic oil. But only pine oil is the oil that is used as a frothing agent in froth flotation process. Next is the question number 16. Which of the following metals is not extracted by leaching? Options are aluminium, B, mercury, C, silver, and D is gold. So which of the following metals is not extracted by leaching? इनमें से कौन से metals है that are not extracted by the leaching process? Either aluminium, mercury, silver, and gold. And it is the question number 16. So out of these following metals, the metals that are not extracted by leaching is the mercury. So mercury is the metal that is not extracted by leaching. Mercury is the metal that is not extracted by the leaching. Is not extracted by leaching. Is not extracted by leaching. Next is the question number 17. Sulphide ore of zinc, copper is concentrated by froth flotation process, electromagnetic process, gravity separation, and distillation. Sulphide ores of zinc and copper that is concentrated by either froth flotation process, electromagnetic process, gravity separation, and distillation. So which is the right option for the question number 17? So sulphide ores of zinc, copper is concentrated by froth flotation process. Not froth, but flotation process. Flotation process. So here this is the right answer. That is the flotation process. That means sulphide ore of zinc and copper is concentrated by flotation process. Next is the question number 18. The electrolytic reduction technique is used in the extraction of, option A is highly electronegative element, B, highly electropositive element, C, metalloids, and D is transition metals. The electrolytic reduction technique is used in the reduction or in the extraction of either highly electronegative element, highly electropositive element, metalloids, and transition metals. So the electrolytic reduction technique is used in the extraction of highly electropositive elements. Highly electropositive elements. So the electrolytic reduction technique is used for the extraction of highly electropositive element. Yes बेटे 17 का बिल्कुल सही आंसर दिया है आपने. वेरी गुड बेटा. नेक्स्ट इज क्वेश्चन नंबर 18. and the electrolytic reduction is used in the extraction of highly electropositive elements. So this is the right answer. Question number 19. Which ore can be best concentrated by froth flotation process? Options are malachite, B, casterite, galena, and magnetite. Which ores can be best concentrated by froth flotation process? So the ores that can be best concentrated by the froth flotation process is galena. So galena is the ore that can be best concentrated by froth flotation process. Not casterite, not malachite, and even not magnetite. But galena is the ore that can be concentrated by the froth flotation process. So here this is the right answer. Next is your question number 20, and this is our last question for our today's live video lecture. That is your question number 20, because our today's target for our today's live video lecture is of important 20 objective questions or MCQ questions from the chapter that is the general principles and processes of isolation of the elements. Electrolytic reduction of Al2O3 to Al by Hall-Hartlett process is carried out. Option A is in the presence of NaCl, B in the presence of fluoride, C in the presence of pyrolyte which forms a melt with lower melting point, and D is in the presence of pyrolyte which forms a melt with high melting point. So electrolytic reduction of Al2O3 to Al by Hall-Hartlett process is carried by in the presence of pyrolyte which forms a melt with lower melting point, So here the electrolytic reduction of Al2O3 to Al by Hall-Hartlett process that is carried out by in the presence of pyrolyte which forms a melt with lower melting point, and this is the right answer for the question number 20. Not in the presence of NaCl, not in the presence of fluoride, and even not in the presence of pyrolyte which forms a melt with high melting point. So here this is the right answer for the question number 20. This is the right answer. Very good बेटे, बिल्कुल सही आंसर दिया है आपने. क्वेश्चन नंबर 19 का सी ऑप्शन जो है that is the right answer. So here बेटा, this is all about for our today's live video lecture, and the name of the chapter is General Principles and Processes of Isolation of the Elements, and this is chapter number 6. And regarding this chapter, today we will discuss important 20 MCQ questions or objective questions. So बेटा, कल हम आपके साथ नए लाइव वीडियो लेक्चर में नए चैप्टर के साथ नए ऑब्जेक्टिव क्वेश्चंस के साथ दोबारा मिलेंगे. तब तक आप इन क्वेश्चंस को गो थ्रू करें एंड रिवाइज करें. सो वंस अगेन गुड नाइट टू ऑल द स्टूडेंट्स हु ज्वाइन विद अस आवर लाइव APS क्लासेस.